Hello world! This is a new video talking about the vr.vex.com website, and this video is specially made for Blake. His dad got a hold of me, let me know that he is interested in getting involved in robotics. He's a little young to really get going with our hands-on teams, but this is a great way to start getting involved while at home, especially during our current lockdown situation. So Blake, this video is for you. I want to talk about this new virtual world that VEX VR system has put out. So as you can see here, it says VR and it's the VEX Code project. So this can be found at vr.vex.com. So let's talk about the layout of this website a little bit. As you see over here on the left-hand side, there's a number of different things. And the very top, you notice it says Drivetrain, and that correlates to what we see in the far left-hand side. So there's a lot of different things that can be put into these programs based on what's available on this left-hand side. So let's just review what we have here. As I mentioned, in the top left-hand corner, we have Drivetrain. Then we have Magnet. So that'll get into something that we'll do a video about in the future. Then looks, so you can actually put things in here. So you notice here the set print color black. You can do a lot of different things with this. Control system, you can make some decisions based on some of the variables. Now that might be getting a little bit deep in the woods if you're just getting started, so don't worry about it if that seems a little bit complex, but you can make decisions with these yellow bits of code or orange bits of code here. So notice how you have if else or if then. There's some really interesting things you can do. For example, like if the wall's close, then turn to the left, or if I'm going to run into something, don't, right? So once we put in the actual programming side of things, you can start making decisions on your within your robot once we get into that complex stuff here. So let's move on to sensing. So I mentioned how it can determine if it is close to a wall, for example. So that would be like down here where we see eye sensing. Right here where it says front eye is near object or front eye detects something. Those types of things, or for example right here, distance. There's a lot of different stuff that can be pulled in here and you can make a decision of what your robot should do based on how far away things are, what it sees, if it runs into something. There's a lot of really cool stuff that can happen in here, and we'll get into that a little bit down the road. Next thing here is called operators. So this is where you can add, subtract, compare numbers, compare variables, do a lot of different things. And as I mentioned earlier, this is getting a little bit deeper in the woods than the very beginner stuff, but I just want to mention what this stuff is. So you can make decisions, like I mentioned up here with control, based on different numbers. So if, for example, say our distance is less than 50, then we can make that decision to stop driving. Stuff like that. That's where these come into play and your variables. So if you see something, say that you do a detection on an item, you can store that number, like say it's 24 inches away, for example. You can store 24 inches into a variable, and that's how you can then use those things up above to make decisions. If I've saved things into a variable, I can say if that's greater than this other thing, then I'm going to make a decision to turn left versus turn right because I have more room in the left-hand side, for example. My block, so if you specifically make something dedicated just to you, you can put that right into here. And comments. So comments, if you put the comments in, you basically can just start writing whatever you want. So you can, in essence, write a note to yourself of what the point of that part is, or you can write a note in here if you're working with a team so somebody else can see what you put in there and why. This is basically just putting a comment in the code so you can keep track of what's going on besides just having all this code. If you go back and look at it in a month, for example, you might not know what's going on. And let's talk about right here, this top right hand corner, you have playground, start, step, stop. Okay, so the playground, that actually opens up the field that you can make your robot drive around on. Start, once you push that button, it'll actually run through the program that you would have over here with these blocks. And then step, you would be able to individually move forward one step into each little block of code. And then I'll open up this playground so you can kind of see what's going on here. So the playground is the field that your robot is going to be virtually driving around in. Notice it still says loading playground, and I'll expand this a little bit when it fully loads. So when you're able to drag off this left-hand side and put the code right here, when you hit that play button, then your robot in your playground will execute whatever you have over here in these blocks. So as I mentioned, I like to expand that just so you have a little bit of a larger view. Then let's talk about what we have here for this layout. Notice over here on these buttons on the bottom right hand corner of the playground view, you have a bunch of lines and what looks like a spreadsheet. This button turns on and off your sensor values. I prefer to have that on so you can kind of just watch as things change, but if you push that button, it will go away. And then down here in the bottom right hand corner, you have two different camera view options. So what we have right now is this top down view. So in essence, you're like up above the field looking straight down on the robot playing field. You can also push this other button. It's almost like you're in a little helicopter flying around behind your robot. So this way you can kind of see what the robot is seeing directly in front of it. I really like to have or like to use the top down view. That way you're able to see everything that it's doing as well as its surroundings, where you don't get to see a whole lot, say, off to the sides or even behind the robot if you are doing the reverse or the fly behind type of a view. So let's work on making a very basic program. Now that we have our playground up and running, and then we have this little block here that says when started. So when you push the start or the play button, it's going to start right here where it says when started. I'm going to leave my comment right there, and I'm just going to make it drive forward, okay? So in order to do that, I'm going to do the drive forward 4. You can also choose, if you wish, to simply do a drive forward. Now the problem with doing drive forward, once you tell it to drive forward, it's going to continuously drive forward. It's going to end up running into this wall. So I don't want it to run into a wall. So what I'm going to do is bring back my drive forward for a set period or a set distance here. So drive forward 4, and this is set to 200 millimeters. Now since Blake is a US young man, I'm going to push this in inches, so it might be a little bit easier to understand. So if you look at your dad's tape measure, for example, you can see inch marks right on that tape measure. And I'm going to choose to go with 48 inches. And if your dad opens up his tape measure and you can see where 48 inches is, that's going to hit that 4-foot mark. So this robot will drive 4 foot straight forward. And then since I now have some code in here, I'm going to put in the comment, drive forward for 48 inches. Just that way I can keep an idea on what's supposed to be happening on the code right below. There's a lot of different ways you can do comments. I just want to show you what that comment can actually do, and you can basically define what you're doing in regular US English language or whatever you want to type if you're in a different language. All right, so we have this drive forward for 48 inches. So I'm going to go ahead and push play, and I want you to watch these blocks. When you push play, it actually highlights the block so you can see where it's at in that program. So I'm going to hit play here. So when I hit play, notice it turns to a square. You see the green highlights what's actually happening at that time. And watch our robot. Now we've moved forward. It's gone forward. It's determined that it's gone forward 48 inches. Or you can also see a conversion right here in the top right hand corner of our playground. 48 inches converts to 625 millimeters. Okay. Now since I pushed play and the end of the program just is that drive forward portion, it's actually still playing. So the robot program is still running, but there's nothing actually for it to do, so it stopped. If I want to stop the program, I have to actually push the stop button. That stops it from running. And now if I want my robot to come back to the starting position, I have to push this little circular arrow button. Pushing that circular arrow button will reset my entire field. Okay? Now my robot is back down here at this bottom right hand corner, and it looks like I was incorrect with what I just said. The distance marker, this distance is actually giving me the distance off of the sensor, the distance sensor on the front. So that's kind of cool to see that difference there. So that distance did not tell you how far it moved. That's actually showing the distance marker. And for the sake of demonstrating that, since I said something that was not right, I'm going to push play, and you can watch how that distance sensor, it should show me a distance that is reduced as it drives forward. So let's watch it. It's at 1,800. Now it gets lower and lower and lower. That means we're getting closer and closer to the wall here. That's the very top. So that's kind of cool. I thought that was a distance tracker so you could keep an idea on how far you're going, but it's actually showing you the variable or the value coming off of the center that's shooting forward. So that's pretty slick. All right, so let's go ahead and get back to driving our robot with our program. Oop, and I push start again, so I'm going to hit stop. I'm going to do my resets a couple times just to make it reset all the way back in the corner. So driving forward is really cool, but we actually want to do something. What I'd like to do is drive forward and do a nice big square and see if I can get it to come right back to its starting position. So since I drove forward for 48 inches, my first thing I want to do is turn to the right because I can't really turn left. There's a wall right there, right? So let's turn right. Now we can grab this thing over here that just says turn right, but there's no definition there. We don't know how far it would actually turn. So since we're working with robotics and we're working with this virtual world, we want to give it some defined information so we can tell it to do exactly what we want it to do. In order to tell it what we want it to do, we're going to drag this one over here. This says turn right for 90 degrees. Now you can change your right and your left. If you do this drop down, choose right or left, but we can't turn left because there's a wall there. So I'm going to keep it on right, and 90 degrees is an exact right turn. So with that turning, to explain how 90 degrees works, is in a circle you have 360 degrees. If I turn right, if I want to go exactly to my right, then that is a 90-degree turn. If I want to turn all the way around and look behind me, that's a 180-degree turn. If I want to turn to the right and end up facing off the left, that means I'm going to make almost an entire circle off to my right, and that's going to end up being 270 degrees turn to the right. And if I wish, I can turn all the way around. Basically, my robot will just sit there and do a little spin. I can do a turn right 360 degrees. It'll spin all the way around and come right back to where it started. But what I'm going to do here is just stick with my turn right 90 degrees. Now, since I'm trying to draw a box or make the robot drive around in a box, once I've turned right 90 degrees, the next thing I need to do is go forward again. So Blake, hopefully you're following along here, and I am going to drag my drive forward over here again, and I'm hoping you can do this at home as well. Anybody who has access to the internet and a decent little computer, doesn't even have to be that powerful, can access this vr.vex.com system and work on making robot programs from home. Pretty slick little system that they put out. Again, I'm going to switch this over to inches, and since I want to keep my perfect little square, I'm going to do 48 inches. Okay, now that should bring me over here towards the center of my playing field. Okay, so the next thing I'm going to do is make that 90-degree turn to the right again, so I'll be facing back down. So I'm going to drag my turn right over. So I have it set to turn right, and notice if you let it go out here in this white space, it won't be involved in the program. It's not included. In order to follow along the program, you have to get it close, and you see how it's a little bit gray right there between the two. Get it close, and then you can let go with your mouse, and it'll click right into the rest of the program. You should be able to hear that little click. So turn right 90 degrees. Okay, so we have basically a half of a square here is what I have going on with my robot code. So I am going to do a quick reset and then hit play. So let's watch what it does and keep an eye on how it executes these blocks here. The first thing it's going to do is drive forward that 48 inches. And then it should turn exactly 90 degrees to my right. And once we make that next little 48-inch piece, turn right 90 degrees again. All right, so now we are facing down just like I expected. The next thing I need to do is move all the way down to the bottom of this playground. Since I moved up 48 inches, in order to get back to where I started, I have to also do 48 inches. So since I am facing downward, I'm going to choose to drive from that position. Since we know it stopped right there, then the next thing we can do is visualize I need to come down 48 inches. So if I do a drive forward, I'm going to switch this over to inches again, and then I'm going to mirror what I did for drive up. So my drive forward 48 inches. So that means from that position it's going to drive forward. And the next thing I want to do, since I'm trying to get over here, is I need to turn right again, which means turn 90 degrees to the right. Notice all of this code and the way that you set this up is based on the direction of the robot. So even though from our view it's actually going to be turning to the left, from the robot's direction is turning to the right. That's why we need to make sure to have that turn right on there. So turn right 90 degrees. The next thing we're going to do, again, since we moved over 48 inches, is we need to we need to drive forward another 48 inches. The next thing we need to do is drive forward 48 inches. So let's drag this down, drive forward, again, switch that to inches, and then we're going to do 48, because that's the number we've been sticking with so far. And then, since I want to get right back in the starting position, that means I need to turn to the right again, so I will end up exactly where I was when I started. And I'm going to hit stop, and then I'm going to reset, and notice that's facing straight up. So if we look at this program here, the first thing I'm going to do, just like we've seen when we executed it before, is we're driving 48 inches forward. Turning right, driving 48 inches forward. Turning right, driving 48 inches forward. Turning right, driving 48 inches forward, and turning right again. Since we have 4 of these 48-inch drive forwards, and then we have 1, 2, 3, 4 90-degree turns, that means we're going to make a box. So let's go ahead and execute this from the starting position, and the robot should end up all the way back where it started. So I'm going to push my play button, and it should execute that program, and you can see where it is in the program by how the green highlights the blocks right there as it moves down on the left-hand side of our playground. Notice that's where we stopped last, so it's going to turn right, go down to the bottom, so we're doing that 48 inches down to the bottom, and it's going to turn right again, and it should move 48 inches again, and we'll turn right and get back to our starting position. There we go. Exactly what we expected to happen. I think that's pretty cool. Hopefully you were able to do that without too much difficulty. Now let's add a little bit more fun to this. Okay, so since we are back in that starting position, let's do another drive forward, but we'll start playing with our direction turns a little bit. So I'm going to drive forward, but this time I don't want to go quite so far forward. Okay, so drive forward, let's do it again in inches. And instead of doing 48 inches, we'll do 24 inches. Now again, if you want to visualize this, you can take a look at your dad's tape measure, or if you have a tape measure of your own, you can see 24 inches is 2 foot. Okay, so it's going to drive forward 2 foot. And that's exactly half of what it used to be doing. We were driving forward for 48 inches, and now we're going to be driving forward for 24 inches. So again, I want to make a turn. So I'm going to take my turn and drop it right here below. But this time I don't want to do an exact right turn. Now I mentioned if you want to do a right turn, it's 90 degrees, or if you want to turn all the way around, it's 180 degrees. But you can do smaller than 90 as well. If we take 90 and divide it exactly by half, we end up with 45. So a 45-degree turn will be half of your 90-degree turn, and it'll basically give us a little bit of a diagonal direction. Okay? So if I essentially will be moving forward 24 inches, and then I take that 45-degree turn off to my right. And then what I'd like to do is drive forward again, but this time I'm going to do 36 inches. So that is going to be a little bit less than our 48 inches, a little bit more than our 24. It's right in between there, and that will be 3 foot or 36 inches. Okay, so that means I'm going to be driving forward, doing a diagonal, driving forward on my diagonal direction. Now what I'd like to do is get that robot to show up, or get that robot to reorient itself in the same direction so it's facing straight up again. And in order to do that, I need to counteract this little diagonal turn that I did right here with my turn right for 45 degrees. So right after it drives forward for 36 inches, I'm going to do a turn left. It's the first time we've done that one. So I'm going to take this turn left, drag it down here, choose left, And now since I did 45 degrees to the right, if I do 45 degrees back to the left, it will end up facing straight up. So now that we have all that, let's go ahead and run this program and we'll see how this turns out. I think it'll work exactly the way I planned. I push play. It should do first, it should go through our box, and then it will go through our new section. So we can watch it execute, and hopefully you are following along with me and running these programs, and your program is doing the exact same thing. If you seem to be having problems or it's not quite doing what you expected it to do, go back and see what blocks it's executing at the time, what you expected it to do versus what it's doing, and try to see in the code what you told it to do. You might have told it to do something that's not quite what you want it to do. So here it comes to our new section. Now we're driving forward 24 inches this time. There's our 45-degree turn, moving forward 36 inches, and then a 45-degree turn to the left. All right, so here we are facing straight up, just the way we were when we started. So we are now oriented straight up. Again, what I would like to do is find my way back to the starting position. So I think one thing I'd like to do, since we haven't done it before, is let's do a drive backward. Okay, so we'll do a reverse. I'll switch this over to inches. And let's take a think here about how far we might want to move. So since I drove forward 24 inches, and then I turned to the right 45 degrees, and then I drove forward 36 inches on a diagonal, and then I turned left 45 degrees again. I think what would be quite interesting is to take that forward movement that I did right at the beginning and mirror that with my backwards movement. So if I drive in reverse, and we switched it to inches already, let's go ahead and drive in reverse for 24 inches. So that should bring me back down just about right here where my cursor is. So it'll be about 3 blocks from the bottom. Let's stop it because it's still running the previous one. Okay, I'm going to reset this. Now let's think about if I'm backwards and I would like to get back towards where I started. So what I would say we could do is instead of turning all the way around, we could turn left and try to counteract the direction we've done so far. If we want to turn left, exactly left, it's going to be that 90 degrees. Let's go ahead and bring up a calculator and we can talk about how to calculate what we want to do for our turns. Since when I was facing to the top there and I wanted to turn a little bit to my right, I did 45 degrees. So I'm going to bring the calculator over here. So now if I'm facing forward or up like you see there, but I want to end up back here to my bottom left-hand corner. So if I turn to the left, exactly left, we'd be at 90 degrees, okay? So since we did a 45-degree turn to get where we are, I need to add 45 degrees to this, and that will give me an exact replica of the backwards angle of where I was. So since 90 degrees is exactly to my left, let's go ahead and add 45 equals 135. So that would give me a direction back to my corner. So let's make a left turn at 135 degrees. Okay, so since the first thing that I did right here was drive in reverse, I'm going to take and do a turn, left, and I'm choosing to go left at 135. Okay, so let's reset this field and we'll watch what it does with that last little bit of driving backwards and then turning left for 135 degrees. The first thing it's going to do, as you can see where it's highlighting in the left-hand side, is do that little 48-inch block that we did at the very beginning of this program. Since it's at the top, it always executes that part, and we have to work our way down to the new thing that we just created. It's working its way down to the bottom right-hand corner, and then it'll go back to the starting position. Once it gets back to that starting position, it'll start executing the new section of the code that we just did. Okay, so that's where we have that 24 inches, 45-degree turn, and then we're going to do a 45-degree turn to the left, and then it's going to go backwards. Here we are backwards. Now this is our whole new section, 135 degrees to the left. Now look at that. It's facing exactly back to the corner. Okay, so now since we did 36 inches on the diagonal to get to where we were, we should be able to do 36 inches to get me right back to where I started. And then I'm going to need to do another right turn. Okay, so let's go ahead and do my drive forward and drag that down. And since we did our diagonal after our 45 degree at 36 inches, let's see what we can do with a diagonal going back to our position at 36 inches. Okay, so now we'll be facing this direction down here in the corner. Okay, so since I turned 135 degrees to get from facing straight up to facing this location, I'm going to need to turn to the right and face straight up again. Now if I turn right 90 degrees, I'll be facing a diagonal. So again, we're going to bring this back over here. Since I want to turn to get back to where I started and I turned to left 135 degrees, now I'm going to turn right 135 degrees, and that should bring us right back to our starting position as well as our starting orientation. So let's drag this block over for turn right. Drop that in after the 36 inches. And we'll put 135 degrees. Okay, so since we turned left 135 degrees to get this orientation and be facing down this way, we're going to turn right 135 degrees to get back to where we started. Now, the only thing that might happen is when it gets too close to this wall, it could have a problem where if it tries to turn, it might smack into that wall. But it might be just perfect. So let me hit the stop button. I'll do a reset, get it right back to where it started, and then we will do a play and see how this runs. As we've seen many times before, the first thing it's doing is doing that little square for us. So this is really cool because it just goes through, does the thing that we've learned how to do. It'll execute all the stuff in our program, and then we're just continuing to build on top of it. So it's basically just making this continuous drive program and doing exactly what we tell it to do. Once it gets back to that starting position, we should then see it start pushing into that new section where we do the 24-inch movement and then the diagonal. So here we are with the 24-inch movement. Make that 45-degree turn, 36 inches, and then a 45-degree turn to the left. Now we're going backwards, and here's our new section with 135 degrees. It's going to push 36 inches right back into our corner, and then we need to make that final right turn. Here we are with that final right turn. We're right back to where we started. I don't know about you, but I think that's pretty stinking cool. All right, that is the end of the very first program we have going on here. I hope you learned something, Blake. I hope this was fun for you. You can certainly make a decision to mess around with this a little bit more. You can add some different driving around. You can do a lot of really cool stuff. I'll be doing some more videos for you, and if you'd like, you can follow along with us and just write programs at home, and then hopefully soon you can join our competitive team. Blake, I hope you learned something. I hope you had a great time. I hope everybody else learned something. Please like, subscribe below. Thank you for watching.